because wrong. Went to the wrong place. Here, how do you find volume? Well, first of all, you need to know the name. So first things first, let's talk about prisms and cylinders, and they should be together. We're not doing these. I pulled these from review worksheets. I'm just doing this for practice sake about what you need to know on how to find volume. So what is volume when you have a prism or a cylinder? Very simple formula. Big B times H works for all of these. Every single stinking one of them. Okay, the problem is, what is big B? That was the one thing you had to, focus on and memorize and take care of. Well, big B is the area of whatever the base represents. So in the first one, this is called a rectangular prism. You can fight what is the base. Usually we just say the bottom, but that's not the case on this one, so you got to be careful. But these you're fine. So we call this the area of the base. It's length times width, because that is the area of a rectangle. And then this represents, obviously, the height. I didn't want to get into this, but I'm trying to get you to understand what big B represents. So this is okay. Here, which is the base? Well, it's actually this circle. The base of a prism and or a cylinder is what connects, is connected by what actually is essentially the height. So big B on this is a circle. So what's the area of a circle? We just talked about that. Pi r squared. That's big B. What's H? 6. Okay, what's this? This is a triangular prism. So what's big B? The area of the triangle. What's the area of a triangle? Half little base times height. And luckily you have a right triangle. But I said I wasn't going to do these like as with numbers. So, and then what's 10 represent? Absolutely nothing, because it's not the base or the height of this triangle, it's just the third side. The reason this represents the base and the height of the triangle is because it's a right triangle nicely. And then this is the height. The height of the prism is the connector of the bases. Can you see that? So that'd be 9. But we're not doing these. I'm just saying that, let's call that like capital H, height of the prism. So that's where 9 would go. Blah, blah, blah. This is a trapezoidal prism, and I'm not going to bore you with the details, but you'd find the area of the trapezoid, and then this represents the height. So that's what would go in there. For pyramids and cones, it's one minor difference. And we did a little, at least we referenced the water example on this with our nice little, well, I didn't have them, but I talked about it. I left them in the office, so, but no big deal. That's a personal story. It's 1/3 big B times H. All right, well, I can actually do these examples when we get to the worksheet. I just have 2 of them because you either know or you don't how to work these formulas. On the Park exam formula sheet, though, there are some specific things listed. But the general big B times H and 1/3 big B times H, not done. Well, actually, yeah, it is. General prisms, volume equals big B times H. And it does have pyramids, 1/3 big B times H. All right. And then cone's a little bit more specific. So it's on there. All right. So I don't know. I'm just going to the worksheet because just probably we're good with this here. All right. So the first one, I'm going to do 16. You do 17 because look at it. 17 is pretty standard. This is a triangular prism. And yet again, so nicely, I gave you a picture that has a right angle in it. So this is the base. This is the height. Because a triangle, the right angle, this stands straight up and down. So this could represent the heights when this is the base of the triangle, not the prism. The height of the prism is the connector of the triangles. That's where we had a real rough time with this. So this is big B times, I'm even going to color code this, all right, times H. So what's big B? An area of a triangle, which is 1/2 8 times 15, times H, which is this 8. Just happens to be the same thing as the other 8 that we have for the triangle. So figure it out. 1/2 of 8 is 4. 4 times 15 is 60. 60 times 8, 240, last time I checked. Meters cubed. The reason it's cubed is that's how many 3-dimensional cubes would fit inside this. Is that a cube? I don't even know. Okay, I tried my best. All right, pretend that's a cube. Pretend that's a 1 by 1 by 1 cube. There's 240 of those in there. That's what that means. All right, let's move on. All review, 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 review. All right. Oh, good. I thought I missed it. Oh, composite figure. That's nice. All right. So then find the missing dimensions. This requires you read and actually get an idea of what this picture is. So I got one over here about a cylinder too. I should have done that one. Yeah, I'm going to do that one. You do number 18. 19, a cylinder has a height, whoa, of 23 meters. Its volume is 207 pi meters cubed. Find the radius of the bases. The cylinder has 2 circular bases. It's an awesome drawing. So volume equals big B times H. Big B is pi r squared times height of the prism, and that equals 207 pi because that's what the volume is given as. So what do you do about this? You fill in what you got. And what you got is 23 for the height times r squared times pi. I want to go over this too fast, but this should not be a game breaker here. How I get r squared solved for is divide by pi, but also divide by 23. So basically you can divide by 23 pi in one shot, and you get r squared all by itself right now. Go to your calculator. Oh boy, mine looks a little weird. I can't even see my buttons. Well, that's weird. 2, where's the 0? Oh, 7, where's the divide button? Divided by 23. Love this computer. Hey, that's nice. 9. So what does r equal? Root it. And r equals 3. Boom shakalaka. All right, and then the last one of the day. Why did I do this? I don't know, because I thought it was fun. It actually just came from either notes or I don't know where I got it from. Another class, I think, that I teach. Hey, what's this a picture of? This is a picture of a cone. Hey, what's that cone attached to? A cylinder. So this is just a composite figure that if I want to find the volume of the whole thing, this is cylinder plus cone. We had a lot of those on the test and reviews when we did that kind of stuff, so you can do this one on your own. Cylinder. Volume of a cylinder is big B, which is pi r squared, times H. Volume of a cone, no, I just covered that one. It's 1/3 big B times H, height of the cone. So what's the radius? Actually, the radius of both of these is 5. So it's pi r squared times. Now, what's the height of this cylinder? 7. What is the radius? Well, we just said the radiuses are equal. Radii, my bad, dogs. And then what's the height of this? 8. Okay? So 25 times 7, that's what I'm going to handle. 25 times 7. You know what? Watch this. Oh, that's going to be complicated. All right, so we get 175 pi. Smart to do that once we see this. And then 1/3. 1 divided by 3 is 0.3 repeating. I'm probably doing this in a weird way, but 5 squared times 8 times that answer that we got, the 0.3 repeating. That could be math fract if you wanted. Boy, that's just kind of a pain. It's kind of getting ugly here, but I'm just going to leave it at 66.6 repeating, because you're not probably going to get something where you have to write the exact. That looks kind of like this kind of question. But to get the approximate, I just take plus 175, really getting into a pickle here. Okay, and then times that by pi. So basically all I did was take 175 plus this in fraction form, and the calculator put it in fraction form, but once I hit it by times pi, this turns into an approximate answer. So it gets rid of that fraction. So basically added these two together, and I got 759.2 millimeters cubed. So the reason I like this question is it practiced another cylinder volume with a cone, and then we just got to know how to use that and do it. Okay, we're done.